Here we have a factorial equation and we have to solve for the variable n. Okay, since we are trying to solve for the variable n has to appear on only one side of the equation, but in our equation, the variable n appears on both sides of the equation. Okay, so we have to get rid of the variable n on one of the sides. Okay, let me get rid of the variable on the left side. For that, I have to divide both sides by n negative 1 factorial, and here also I have to divide by n negative 1 factorial. So n negative 1 factorial over here and here will cancel out. I get n positive 2 the factorial divided by n negative 1 factorial equals to 60. Okay, now what I'm going to do is I have to expand this n positive 2 factorial numerator because this n positive 2 is greater than n negative 1. So to simplify, whenever a factorial is divided by another factorial, always we have to expand the factorial where we have a larger number. So n positive 2 is larger than n negative 1. Okay, so to expand this factorial, let's look at some example to have understanding on expansion of factorial. Okay, let me take 5 factorial. Okay, if I want to expand this 5 factorial, what I have to do is I have to write the numbers from 5 to 1 in descending order, and I have to multiply them all. So I start from 5, then 4, 3, 2, 1, then I multiply all. In case when I expand the 5 factorial, I don't want to continue up to 1. I just want to stop at somewhere else in the middle. For example, I just want to stop at 4. What I should do is I have to put factorial over there, so that when people see this, they can understand it does not stop over here. It continues up to 1. So the result of this and the result of this are same, because 4 factor means it's 4 times 3 times 2 times 1. So when you expand a factorial, if you want to stop at anywhere, you can stop, but you have to take factorial for the number at where you stop. So the same logic I'm going to apply for the expansion of this n positive 2 factorial. Okay, n positive 2 factorial. Okay, when I expand the 5 factorial, first I write the number 5 over here. So the next number is 1 less than this number, and the next number is 1 less than the previous number. So now to expand this n positive 2 factorial, first I have to write n positive 2. The next number has to be 1 less than this. That is, I have to subtract 1 from this one. When I subtract 1 from this one, I'll be getting n positive 1. So the next number will be 1 less than this one. If I decrease 1 from this one, I'll be getting n. The next number will be 1 less than this one, that is n negative 1. Okay, I don't want to continue this expansion up to 1. I just stop at n negative 1. So I have to take factorial over there. So the expansion of n positive 2 factorial is over here. So we can plug in this stuff for this n positive 2 factorial over a numerator. So instead of this n positive 2 factorial, we can write this expansion. Let me do it. So n positive 2 times n positive 1 times n negative 1 factorial divided by n negative 1 factorial. Okay, here when I stopped at n negative 1 factorial, you may have a question. Why particularly I stop at n negative 1 factorial? I think I would have received an answer for your question, because here we have n negative 1 factorial in denominator. Only if I stop at n negative 1 factorial, I'll be able to cancel out this one. So easily I can simplify. So I get 60 on the right side. So on the left side, we have n positive 2 times n positive 1 times n equals to 60. Here, this is a product of 3 consecutive numbers in descending order. So this is the largest, this is the next smaller number, and this is the least. So this is a product of 3 consecutive numbers in descending order. Okay, in case if I multiply all these 3 quantities, I'll be getting a cubic equation in the variable n. So it will be time consuming to solve a cubic equation. So for that, what I'm going to do is I'm going to write this number 60 on the right side as a product of 3 consecutive numbers in descending order. So if I write this 60 as a product of 3 consecutive numbers in descending order, I can compare these 3 numbers and the 3 numbers what I'm going to get on the right side, and I can easily solve for it. That's my idea. Okay, how can we get 60 as a product of 3 consecutive numbers? Okay, for that, what we need to do is we have to decompose 60 into its prime factors. 60 is an even number, so we can divide it by 2. So what do I get? I'll be getting 30 when I divide it by 2. Again, it's an even number 30, so I divide it by 2, I get 15. So 15 is a multiple of 3. I can divide it by 3, so I get 5. Now this 2, 2, 3, 5. All of them are prime numbers. So now 60 can be written as, let me continue this over here, n positive 2 times n positive 1 times n equals to, the 60 can be written as 2 times 2 times 3 times 5. So 2 times 2 is 4, 4 times 2 is 12, 12 times 5 is 60. Okay, n positive 2 times n positive 1 times n. Okay, now we have four numbers, product of four numbers, but we have to write this product as a product of three consecutive numbers in descending order. Okay, it's very simple. When I multiply 2 and 2, I get 4. So it's very simple, 4, 3, 5. So these three are consecutive numbers, but we have to write the product of these three consecutive numbers in the order from greatest to least, because that's the order in which we have the three numbers on the left side. So the greatest of these three numbers is 5. So let me write first 5, and then I write 4, then I write 3. Here we have a product of three consecutive numbers in descending order, that is from greatest to least, and please make sure the product has to be equal to 60. 5 times 4 is 20, 20 times 3 is 60, that's correct. Okay, here the product of three consecutive numbers in descending order is equal to the product of three consecutive numbers in descending order. Since the products are equal, we can equate the smallest number or least number on the left side and least number on the right side. So n must be equal to 3. So I got the value of n. So the value of n is 3.